Okay, so today's problem is another jump game. So the LeetCode is literally giving every jump game problem, and these are very interesting actually. These problems are. So let's see what it means. So again, jump game, that means you have to traverse from one index to another index. So let's see what is the condition here. So there is an array of integer array R and integer D. So one step you can jump of index I to I plus x. So where I plus x less than the array length and x is 0 to D. That means there are integer D is given. So D is nothing but the maximum. There is a limit you can jump. Okay. So from 0 to you can, sorry, it should be not 0, it's from 1 to less equals to. So you can, if integer D is 2, so you can move here one index or two index, or one index here or two index here, like that. So you can jump like I minus x, that is the case. Same thing, that means if index is 0, 1, 2, 3, 4, 5 is there, and D, let's say D equals to 2, then you can jump from, let assume you're here, and you can jump here, you can jump here, you can jump here, and you can jump in this case. These are the possible scenarios. These are the set. So we cannot jump in a fixed position. We are going to jump in a range. Within a range, we can jump. So what is the range of that? If it is my ith index, I can jump I minus D to I plus D. In this range, we could jump actually. Fine. But that is not only the case. There is another condition. Okay, so this is the next condition. So in addition, you can only jump index J if index I is greater than index J, and all the elements between the I and J is less than also I, error of I. What I am say, more formally, minimum of Ij is K and maximum of Ij. So for an what I actually mean to say, let's say our index is again 0, 1, 2, 3, 4, 5, 6. What could be the value? Value is what here? Let's say 7, this is 4, this is 3, this is 8, this is let's say 2, let's say 6, this is 7. Okay. So for an example, so I'm giving a very bad, no, very good example, whatever. Let's say D equals to 4. So D equals to 4. Okay, so let's see what are the index position we could sum. For an example, so let's start from the beginning in this place. If D equals to 4, what are the possible cases we could jump? So starting from I plus D, like from I minus D to I plus D, in this range we can jump anywhere, right? So here it is, in the left side I can jump, for right side I can jump, right? So ideally I could jump here, here, and here, and here, these four places, right? But there is a catch. You can jump any index if error I is greater than error of j. Okay, so move this thing as 9. So if your I is here, you cannot jump in this position. You cannot jump in this position. Okay, so it's not possible. So what are the other cases? So error I is greater than error j, then I can jump. What are the other cases? You can, if you think of it, if this is gone, this is gone, then I can jump here, here, and here. This three index, like this three index, I can jump clearly, correct? So, but there is another case. I can jump to where error I is greater than error of j index I can jump if and only if all the elements between this, between I and j, all the index, so all the values, that also be less than my current value of j, right? But that should also be less than my current value, current value of ith position. That means I can, ideally I can jump here, but to jump this index 0 to second index, all the in between indices, that those values are also should be less than my uh, ith value. So here 9 is greater than my ith value, so I cannot jump to 8 value. So that means from 7 I cannot jump any other place. I cannot jump because to jump any other place apart from 1, I have to, that means there are something, like you can say there is some barricades are there. You cannot jump over the barricade. Okay, so you can jump only where the places are actually lower than your value. As simple as that. So let's say this is case like 6 is there. So I can jump here because this value is less than my 7. I can directly jump as well here because this 3 is less than 7, and all the values between 3 and 7 are also less than my current value 7. So if my I is here, why it is not working? Yeah. If my eye is here, so I can jump from here, I can jump here, I can jump here, but I ideally I can jump here as well, but there is 8. That is my greater than my value. So I cannot jump in this place. That means I can from this 6th index I can jump only 4 and 5 index, not more than that. This is the case. Hope you understand. Okay, let's see the constants. Constants are literally very low, 1000. I don't know why they have made this thing as low. It could be higher than that because we can solve literally in a very, we can find one solution that can be much lower than this. So the thing is 1000. So that means if we do n square approach, it should also work. N square is also work. Okay. So length d value could be 1 or could be error of length. Okay, fine then. Let's see this example. So here we can see what, like, this is my error. This is a pictorial diagram of that. So I can, okay, one thing I forgot to mention here. Notice that you cannot jump outside of the array and you can choose any index as a starting. Okay, you can choose any index of starting. Return the maximum number of indices you can visit. Maximum number of indices you can visit. Say this is the maximum number of indices, not maximum number of jump you can do. They didn't ask you. So maximum number of indices you have to visit. That's why you have to do one thing extra. We'll see. So what is the special cases here? Let's start from here. From 6, D is 2. So where can I jump? From 6 I can jump 4, but 4 I cannot jump anywhere. So if you notice carefully, I can jump if my current value is strictly greater than any other value, and in between there should not present any other cases. There should not present any other cases, like any other higher value than my current value. Correct. So what I am saying, okay, okay, let's see what could we do. So if it is the d equals to 2, from 6 I can jump 4, so it is not a good case. For 14, from 14 where could I jump? You can jump from 14 to 8 because d equals to 2. So I can jump 6 as well, I can jump at 8 position as well. So better to jump as the highest value because from here I can get another jump. So this is my pictorial representation. I will say like from visualization I am getting there. In logical case we will see what we could do. For 4 to 8 I can jump, 4 to 6 also I can jump, so better to see 4 to 8, and 4 to 8 I can jump 8 to 6. So there are two jump. So how many indexes I am visiting? This is 1, this is 2, this is 3. So 3 indices I am visiting. I am doing 2 jumps, jump 1, jump 2. But in the number of index I have to return number of index I have visited. Number of indexes are nothing but 3. Okay. So from 6, I cannot jump anywhere. From 8, can I jump? Yes, from it I can jump 6. See here, there is a one pattern. One, if you notice here, from 14, I have jumped 8. From 8, I am jumped 6. So I have to calculate the lower value first, or something, or 8 value. So if I 14, if I start from here and if I backtrack at 8 or 6 anywhere, and then 8, from 8 I can calculate this value of 6 as well. So when I start reach at 8, I can already see like, okay, uh, from 8 I have already calculated, from 8 I can jump to 6. It was already calculated from the 14. Okay, okay, right now please leave the point, I will comment later again. So the thing is next, then in 13 where can I jump? There are two places, like you can jump 8, I can jump 6, I can jump 9, I can jump 7 as well. So let's see how many jumps are possible here. 13 I can jump 6, only one jump, sorry, only two visits visited, like 13 and 6, two visits. So that is not a good case. On 13 I can jump 8, and 8 I can jump 6. So 3 indexes are visited. So let's also write down the number. From 6 I can visit only 2 index, like 6 and 4. For 1 we can visit only 1 index. From 14 I can visit how many index? 3 index. 14, 8 and 6. From 6 only 1 index because from 6 we cannot jump any other places. From 8 we can jump only 2 index. From 8 we can jump 8 and 6. So 13, from when I'm 13, 13 I can jump 8. From 8 I can directly get, I can visit 2 index. I don't need to traverse 8 again. So this 2 plus 1 is 30. So it will be 6. Correct. So 2 plus 1 will be, sorry, 2 plus 1 will be 3. So 3 jump possible. From 13 to 9, from 13 to 9, one index. From 9 to I have to calculate 7 as well. Correct. From 9 to I have to calculate 7 as well. So you can see it's a kind of a recursive problem. For 14 I have to check how many cases I can jump, and for every cases I have to check for each individual come to next case, and then I have to calculate the next step. So it is kind of a recursive problem that we can understand. Let's see what we can find again. So 3, from 3 like 13 to 9, from 9 I can jump where? I can undo 7. So 9 I can jump to only 2 places, like 9 and 7. From 7 I can visit only one place, that is only 7. So right now I left us 3. Now is it updated? From 13 I can jump 9. 9 will say like I can, from me you can, like from me you can reach two places, like including me you can reach 2 places. Me and another is 7. It will 2 plus 1 3, so it will not update, so 3 is the maximum number. From 10 where can I jump? From 10 I can jump 6, I can jump 7, I can jump 9. So 9 is already calculated. So when I go to 9 with one case, like 13, like only 10 is already one visited index, then I can jump this one, like not 10, it's not index, 8 is the index, so 10 is one of the value I have visited, then I can jump to the value at 9. Then 9 I am get, from here I can get 2, so 2 plus 1, this one index, so that will be 3. So 10's current value is 3. Okay, 10's current value is 3. Cool. Okay, so 10, from 10 here I can jump 6 as well. So 6, where can I jump? 6 only 1. So 6 will be 1 plus 1, 10 and 6, 2. So it will be only 2. So 3 is the maximum. So I'll take 3. From 12, where can I jump? From 12, I can jump 6 and 10 only. I cannot jump 7 because, why? Because like um, d equals to 2, because d equals to 2, that's the reason I can't jump. From 12 I can jump 1, so what is the case? 1, and from 6 I can visit only 1, that is only 6, and 12, that means 2. So 12 I can get 2, and again I can jump 3, 10. From 10 I can get, it is returning me 3, so 3 plus 1 is 4, so 2 will be updated by 4. So from 2 I can jump 10, and then you can see the mark that is a given here. Okay, so my maximum answer is 4. Correct. So this is the path. Okay, so 4 is visited. Fine. Let's see when the d equals to 4. I written 2. It should be 4. Can I only move 3? No. Okay, it is coming back again and again. Let's see, can I do anything? Let me pause and come back. Okay, if my d equals to 4, starting from 6, again 6 can jump to 4. I cannot jump to higher value, so I cannot go there. From 14 I can jump 6 and 4, correct. I can jump 6, I can jump 8, I can jump 13, I can jump 9 as well. I can jump 9 as well. From, so let's start doing it. So 6 I can do what? 6, from starting from 6 I can say let's go 4. Like what is the possible case? 4 is the possible. From 4 where can I go? For 4 I can go only one place. So 1. 6 will be 2. 1 plus 1 is 2. For 14, from 14 I can go where? 4. That will, it will return me 1 plus 1, that is 2. Okay. Now 4 I can go to this 2 as well. 14 said 14 I can go this 6 as well. From 6 I can get, 6 is already calculated, that is 2. From 6 I can visit, if I start from 6 I can visit 2 indices. So that means it will be 2 plus 1 3. So 14 will become right now will be 3. Fine. The 14 possible cases are what? This is 6, because from 14 I can go to lower value 6. So 6, from 6 where can I go? 1. So 1 plus 14, 1 which is 2. The 3 current now my value is 3. So my 3 is greater. So I have to take lower value. From 14 I can jump 8, because 8 is lower than 14, and between 18 and 14 all are lower than my 14. So again this case will be what? Like it will be written from 8 where can I jump? From 8 I can jump 1, this 6, and 6 is giving us 1. Say like if you start from 6, this 6, you can visit only one index. So that means 1 plus 1, 2, 2 plus 1, 3. That means it is already 3. So it is 2. So 2 plus 1, 3. So it is what is my current index. From 14, right now, 14 I can jump. Now 14 I can jump 13 as well. Now 13 where I can jump? From 13 I can jump here. I can jump here. See here, d equals to 4, right? So, but I cannot jump 14. Even though see 13, even though I can jump in this index because this 4 is less than my 13, but see, this 14 is higher value in the between, like in between 4 and 13, even though it is in a range where I can jump, but in this range, one higher value is also present. So I cannot jump at this place. So from 13 I can jump here, I can jump here, I can jump here, I can jump here, because see, these are the places I can jump. Up to this I can jump, because from left side I can jump these 2 places, from right side I can jump these 4 places. Let's see. Now what I am actually calculating, I am calculating 14. For 14 I can calculate 13, and 13 I am calculating what are the other places. For 13 I can jump here, but I can see like already 6 is done. 6 is 1, so 1 plus 1, 13 becomes 2. Because 13 I can, if I 13 I can jump to 6, and 6 this is only itself I can visit. So that is 1 plus 1, 13 and 6, 2. So from 13 I can jump 8. So 8 gives us 2. Let's say like from, if I start from 8 I can visit 2 index, so I say 2. So 2 plus that 1, because 1 comes from 13, the 2 plus 1 is 3. So 13 becomes 3. Now see in this place 9. 9, from 9 where can I be? 13 to 9. From 9 where can I visit? 9 to only 7, because here I cannot go. It is not possible. So I can only visit 7. So if I only visit 7, okay, there are many things I cannot. Okay, if I go only 7, what is the case here in the 7? So 7 will be gives me what? 7 will gives me 1, because from 7 I cannot visit any other place, right? 7 will gives me 1. Okay, can I move only? Yeah. So 7 gives me, so 9 to 7. So 9 I can jump to 7. So this is 1 and this is 1, 2. So 9 will gives me what? 9 will gives me 2. Okay. And from 13, I can jump to 9. So 3 and 2 are the like 13 and 9. 9 gives me 2, and 13 itself. So 2 plus 1, 3. So current value is already 3. So no need to update. Okay. Another thing, let's say another case, where can I jump? From 13 I can jump 7 as well. So if I jump 7, 7 is already calculated. Like 7 is 1. From 7 I can visit only 1. So 13, if I directly jump 1, what I say, not 1, like 7, it is 1 plus 1, 13. So 1 plus 1, 2. But maximum is already 3. So why to update? Maximum 3 jump. Think of it first, like we are calculating 14 to 13, and we are checking what are the possible cases from 13. So another case, for 13 I can jump 10, because 10 is less than 13 and between everything is less than 13. 10 and 13. So from 10 where can I jump right now? From 10 I can jump 9, I can jump 7, I can jump 6. So this 9 it is already calculated is 2. So from 9 gives 2, and this is 1, 2 plus 1, 3. 2 plus 1, 3. Now if I jump here 10 and 7, 7 gives me 1, 1 plus 1, 2. 3 is higher value, no need to jump. 10 I can jump 6. Now 6 I can only reach one place, that is 6 itself. So 6 will gives me 1, and 10 this 3, sorry, this 6 gives me 1, and this 1 and 10 becomes 2, but the maximum is 3 right now, so it will 3. So 10, from 10 I can reach 3 indices, and from 10 I can reach 3 indices. So I can say what is the case, like from 10, so from 13 I can reach 10 with one jump, and 10 gives me 3. So 3 plus this 13, that will be 4. The current value is 3, but maximum is this earlier value is 3, current value is 4. This is my 4. Okay. So all possible cases of 13 is done. Correct. So 13, so like I was calling 13 from 14. 14 is like see here. Like from 14 I can go 13, and 13 give me 4. Like from 13 I can visit 4 places, 4 indices. So 14 plus this 4, that is 14 means once, and this 4 is 5. That is greater than my current previous value 3. So it becomes 5. Fine. So if you notice right now, then I was calculating for 14 values. Okay. From 14, where can I go? From 14, I was visiting here, I was visiting here, I was visiting here. There is another step left. That is, I can visit here as well because d equals to 4, right? So if I go there, if I check, 9 is already calculated, that is 2. And 2 and 14 itself, so 2 plus 1, 3, but current value is already 5. So I will not update this thing. So after that, I will visit this. You can see these are already calculated. These are already calculated. So no need to calculate. It is already calculated. 13 is already calculated. 9 is already calculated. 7 is already calculated. 10 is already calculated. This one is also calculated. Only value is left. That is 12. That is not calculated. Let's see what are the places I can go. I can go here. I can go here. I can go here. I can go here. These 4 places. So if you calculate this, if I go 9, 9 gives me 2, 2 and this 12, 1. So 2 plus 1, that will be 3. 3. Okay, fine. So after that, I can go here as well. So this will give me 1. This is 1, 1, 1 and 2, but current value is 3. So previous value is 3, so it will not update. But 2, I can go to 10. 10 gives me 3. 3 and 12, this will be 1. It will be 4. This will be 1 and 3 plus 1 will be 4. And this will be current value will be greater than the maximum value. So this will be my 4. 4. Okay, fine. After that, this 4 means I can visit 4 indices. After that, where can I go? I can go where? I can go where? I can go here. So 1 and this 12, 1, so 2. The maximum. So what is the maximum value? Maximum value is 5 indices. If I start from 14, I can get I can visit maximum of indices like 14, go jump here. From here, I jump here. Here, I can jump here. Here, I can jump here. So how many indices? 5 indices I can visit. So that will be my answer. Okay. And another case, let's see, 3, 3, this is given example. So 3, 3, 3. If d equals to 3, okay. In that case, this is 0, this is 1, this is 2, this is 3. The thing this question it is given, I can jump if my current value is strictly greater than, not equal, strictly greater than. So d equals to 3, but see here, from here I cannot jump any other place. From here I cannot jump any other place because everything is same, right? Same value I cannot jump. In this case, answer will be only 1 because if you start from any index here as well, here or here or here, you can visit only one index. That is the index itself. So answer will be 1 here. Answer will be in this case 1 here. Correct? Hope you understand the problem statement. This is the how should we approach. Now simply it's a recursive problem. You can see because from here I can jump and calculate this place and this place. But if you notice, it is a classical DFS problem because I have to check every possible cases from 14. I was checking this one, checking this one, checking this one, and checking this one. And what I have to return actually, if you return the question carefully, first of all, you are saying what? I have to do recursion, right? I have to do recursion. Second, I have to do maximum path, maximum index I have to visit, maximum indices I can visit. So you can see the maximum longest path if you need to find. You can think of it, na? Like you have to find the maximum longest path. So what is the only approach to go for maximum longest path? DFS. DFS is recursive and it helps me to find a maximum longest path. So we use DFS. And every time we also need to check all the cases, like all the possible cases, you have to also find it out. Correct? So let's write the pseudocode. Okay. So it's a function. That is our usual thing. Function. And this function, what can I write? Like find maximum indexes. Okay. What is given? One array is given and one d is given. Fine. Okay. So let's start our directly DFS. So what I have to do, I told you, like Let's say create on DFS problem. Let's say func DFS. Simply, what will be the simple in this case? If I say here, let's say n equals to length of my array. So array dot length, one thing I need. What is the answer? Currently, answer is 0. By default, you can keep 1 because by default answer will be 1. But I am keeping answer equals to 0. Doesn't matter because if you, why answer is will be minimum 1, because see this case. This is the only case you cannot jump. You cannot jump any other place. Even though you cannot jump, the question is how many index you can visit. So you can visit only one index, right? So that is number of index you can visit. So answer will be minimum 1. So you can either you can do 1 or 0. So anyhow I'm getting 1. So it will upgrade it by 0 to 1. And that's why answer is 0. You can initialize answer as 1. Okay. So simple what I told you, I need to do what? A for loop for my index for I equals to 0, I less than n, I plus plus, in I plus plus. In each case, I have to do what? I have to find my case. Like I have to find this solve. I have to call this DFS function. This DFS for that. For DFS for what? I have to calculate this DFS for that specific I. Correct. And this could be give me the maximum. Like it could be maximum of current answer. It can cross my current maximum. That is my answer. Or it could be lower than my current answer. So that's why I have to update answer as so answer will be maximum of the current answer, and I'm calling the function DFS, that is that for that I. For each case, like I can here I don't know from which place I can start. I can start from here, I can start from here, I can start from here. So I have to calculate for each indexes. Like for each indices, I have to calculate like what could be my maximum value. Because they didn't say I have to start from here only. I can start from any indices. So that's why like this will be an answer. And at the end, simply return answer. So this is what I have to do. Return answer. This is my main function. Okay. Okay. Let's calculate how to find the DFS. So DFS you need visited, correct? You need visited. So that if there is a loop exists, like we need a visited array. But here I am not using any DFS, any visited cases, because there cannot be any loop possible. Because if you see here, one possible case are here, if I can jump any places, let's say there's no condition up there from a given index, given this is the case, in this range I can jump any places. If that is the case, then there is a possibility like 13 I can start, then I can come 8, and 8 I can again come back to 13 because I can visit any places if no condition is given. The strict conditions are given. I can jump only if that value is less than my current value, even not equal value, less than. If it is equal value, then also I need if there is another 13 block, see another 13 block is there, then I can jump here, and this block I can also can jump here. So there could be a loop, but here there is no loop possible, because if I can jump here, no way I can jump back. There is no way I can come back to this place. There is no other way. So this is only one way traversal. I cannot come back. So that's why I'm not using any visited array. Okay, so I'm writing my function DFS, simple function DFS, and what I'm passing, I can pass ARR as well in the DFS actually. So it is, if you make it global, no need to pass anything. So this is your call. You can pass ARR, its value in, and current index I. Uh, and you can think it is actually global index. If you make this variables as global, then you no need to pass anything. Okay, no need to pass anything. But I am writing the normal pseudocode, so that's why I'm passing. So function DFS, what I need, what I'm passing, I'm passing ARR, I'm passing in, I'm passing one index. These are the things I'm passing. So as I told you, normal case, we first use a DFS, then we memorize this, right? So you all know like we have to do memorization, correct? See here, from when I'm calculating 14, I can calculate here. And from 8, I can calculate here. From 13, when I'm calculating 13, so base case is 14 to 13. 13, I calculate 9. So 9 actually calculates this 7. So we can say no, and again after something I will come at like from 14 I need to calculate 13, from 13 I need to calculate 9. So after I am done with 14, some in future I will come at 13, right? I will come at this 13. So that time I have to calculate this 13 as well. So anyhow I need a memorization. Like if I have calculated already, why should I actually calculate again? I need a memorization, right? So I guess you up to right now, if you're doing the LeetCode hard problem, then you already know how to do memorization. You have to use memorization in the recursion problem. Otherwise, if you are kind of strong enough, that's why you're doing the LeetCode hard problem. Otherwise you will not come to do the LeetCode hard problem. So that's why I'm using memorization earlier. So memorization, I need another thing to, let's say another array I'm using. So let's write another array for memoization. So let's say the name, what is name memoization? What is the best name I can give? It's nothing but an array of length of what? Length of n, 0 to n minus a limit. So I am passing that as well. So in the array I am passing arr, in, I, and memorization memory. Fine. So it is a case, and I am initializing this arr of n with 0 or minus 1. Or 0. 0 means I didn't reach. Let's say 0. Anything is fine. So the thing is, I'm passing memorization here as well. So name here, memorization here. So I'm passing here. So if I have already visited, that means I no need to perform the task. Simple DFS memorization concept. So I write a one if statement in the beginning. If my memorization, this index value is not equals to 0, not equals to 0. Why I am saying not equals to 0? Why it cannot be 0? As I told you, if I stand on any index position, if I stand any index position, that means I can visit that index. And again speaking, I'm repeatedly speaking, in the question it is given, like we have to return how many indices I have to visit, I can visit. They didn't ask how many jump we could do. So anyway, this will be 1, because if I stand on one index, that means I have visited an index. That's why it is 1. It cannot be 0. Got it? So that's why if it is not equals to 0, that means I have already visited. I have already visited. So then return simply. So return that case, no need to check again. Simple case. Okay. So now let's move on the next case. If it is not visited, what are the cases? So what are the things we can see from here? Like we can visit either left or right, correct? I can go to left side or go to the right side and check what are the maximum values of the cases. So maximum case from here, if I come here, I cannot go to left, I cannot go to right. So that time only one will be the case. But if I can go left, I can go right, I will take what is this is normal recursive problem. Like in the recursion, I have to take every possible cases. If I go to left, I can go to right, and I have to take what is the maximum case I can get. My greedy approach, this is I have to visit each and every cases, and I have to know what is the maximum case we can get. So I will do what? I will initialize two variables, left and right. So left will be 0 and right will be 0. But in maximum I cannot reach anywhere. The left and right will be 0. Okay, cool. So let's start visiting. So up to which where when I could visit. When I could visit. Let's take this example. This is a good example, right? Let's take this copy, copy and paste. Okay. Is it fine? Okay, let's put this picture here. Okay. As we are focusing only DFS function, let's put the picture here. So the thing is where I can visit from my current index position. I can visit from current index position to D places here and D places here. If and only if I get anything between my what is my current, like say here D equals to 4, D equals to 4. From 13 where can I visit? I can visit here, I can visit here, but I can visit here also, but in between 14 came. So I'll start visiting from this index to this index, correct? Start visiting from this index to this index. If everything is smaller than my current value, so it is fine. I can start visiting, like from here if you see, I can visit here, this, because everything is smaller than my current value. But if I start visiting from this left side, this is fine, this is fine, and this comes here one problem. I cannot cross this one because this is greater than my current value, so that time I have to stop. Simple case here as well. If I get anything value greater than my 13, I have to stop as well, right? So I'll start from for visit left side. I'm starting from my index minus 1, and this obviously this should be the valid case. That is the case, and up to which I minus d by current index is 5. If I jump 4 index, like from here I can jump here, jump here, jump here. Say it's a valid case. So assume this is a valid case. You can okay. Don't take this one. Take this one. So I can take jump here, I can jump here, I can jump here, I can jump here. What is the maximum jump I can do? What is I5? Maximum is 9. D equals to 4 here. So nothing but I plus D. Up to I plus D I can jump. Similarly here, maximum I minus D I can jump here. I can jump here, I can jump here, I can jump here. If it is a valid case, then I can jump here. So minimum is what is the 1? This is the 5. This is 5, this is 1. Difference is nothing but D. So that's why I can jump. If I go to left, I can to jump I have to go left, then I have to starting from I minus 1, what is my current index, to where I can go maximum I minus D. But thing is, it should be inside the limit. So this is 0. So what will be the maximum? That we try to do. I said maximum because this I minus D could be less than 0. That means I can jump up to 0. That means I can jump till 0, or this I minus d could be more than 0, like 1, 2, 3, anything like greater than 0, so up to this. So that's why maximum of I minus d, because I minus d could be negative, and negative means I cannot jump, correct? And for right side, where can I jump? So that means what I said, for left I am jumping from I minus 1, from I minus 1 to maximum of I minus d, or 0, what will be the maximum? And for right, where can I jump? So right, I can jump I plus 1. From I plus 1 I have to take up to which I plus 1, that I plus 1 should be the valid as well. I plus 1 should be the valid. So what will be the range? Max, it will be the I plus d I have to jump, but it should be the n could be, so it could be the minimum of that. Why minimum? Let's say n here is 10. So I plus d could be 9, or could be 11, or it could be 10 as well. So minimum, what is the minimum? I have to jump up to that. I cannot cross the limit. I cannot cross the limit. Correct? Okay. So let's write that. So I have to iterate for each case. So for my this index I starting from my index minus 1, index minus 1. Okay. And up to which, what is the condition? So index should be my less or equals to what is the case, maximum of I minus d comma 0, okay, and I plus plus. Okay, this is a condition of visiting the left side, and what is the condition of visiting right side? So for I will be index plus 1, index plus 1, correct, to I greater, sorry, not greater, it will also be less or equals to, okay, this is not I plus plus because I'm starting from right to left, sorry. Yes, so it is I minus minus. So first it will be 4. If I start from 13, 4, then 3, then 2, then 1. This is how it should work, right? That's why. But here you have to do, I'm going to the larger value from right to left. I'm sorry, left to right I'm visiting. So it will be less equals to what? id plus 1. So it will be the minimum of not n also, it is only n minus 1 because n is an invalid index, n minus 1. The minimum of I plus d and comma n minus 1 in the index cases n minus 1 and I plus plus I have to take for this. So this is the case of my right case, correct? Simple. Okay. And see now I am saying one thing for Python student. For Python student, as I give the code in Python, you have to remember I cannot directly in Python. I cannot directly use this kind of thing. And sorry, another thing, it should be not greater equals to, because I am not less. It should be greater equals to, because see, as I told you earlier, sorry for this mistake. Let me tell this thing again. I am visiting from right to left, right. So index will be first higher, then it will be start decreasing. Okay, so 5, 4, 3, 2, 1. This is how it should decrease. So I have to check. I can visit up to 0. This is the last index I can visit, and after that I cannot visit. So I cannot. It is not. It's an invalid index. So I minus d. Why I am doing maximum? This I minus d could be the -5, -3 as well, negative number. This is invalid case, so that's why maximum 0 is possible. So, so if my I minus d gives me let's say negative number -2 and 0, so what is the valid index I can do? I can do up to 0, right? That's why I am taking 0. By taking maximum, this is I minus d could be 0 or greater than 0. If it is 0, both of them doesn't care. I can go anything. If it is 1, that means my range is up to 1. I cannot go up to 0. My range is up to 1. So I have to take the maximum of I minus d. I minus d and 0. This is the thing I have to. I hope you understand why I am taking maximum. Okay. After that, what we could do? Um, yeah, what I can saying about the Python student. The Python student, if you remember, I cannot write like this sign is not applicable in the for loop, right? If you know already. So it will be in the Python student. What will be the value? Like it will be if you transform this, I have to give strictly less than or strictly greater than symbol in Python. So that will be minimum of. So you have to do strictly greater than. So I plus d plus 1 comma n, because I'm using strictly greater than, and here it will be strictly greater than max of I minus d minus 1 minus 1. Okay, so please remember this thing. Anyhow, so come back in this case. So here, like for I index I and I thing, so what I told you, I can visit this case, but if I suddenly I can configure one kind of higher value than me, then I have to stop the execution. I have to stop the execution. So as I told, if I find out any index like ARR of, if I found anything index I that is greater or equal to as well. If it is equal as well, like let's say 13, if I get 13 here, like here I cannot jump. In this 13 place I cannot jump, because I can only jump if it is uh, strictly smaller, and everything in between them is strictly smaller. So if here not 13 is not present here, assume 13 is present in this place. In this place 13 is there. This is a 13. This is a 13 block. If it is okay, I cannot jump here as well, because I can jump only if it is smaller, and all everything between 13 is smaller, strictly smaller, not smaller or equals to. That's why if I get any value that is greater, like any index that is greater or equals to my current index, that ARR of IDX for which I am calculating. In that is the case, I will break the loop. Break, break the loop. Got it? Same thing will be applicable in the below condition as well. If I get anything like that, I will break the loop. If I don't find anything, if that is not the case, I can calculate my left or right. Okay, so that time my left will be, what will be my left? Left will be the maximum of current left, because see here I can get here, I can get here. So could be one case possible, like I can get maximum value from 6. Yeah, you cannot get, but assume there is this kind of block is present. So you can get maximum value of this from here because here I can jump here. So if I get maximum value from in this place, then I shouldn't upgrade by this. So I have to take what is the maximum I got. So maximum value of that current left, and after solving passing the DFS function of that index, now DFS of I, DFS of I, not I, yes, DFS of I. Okay, this is my left. For right as well, that is same thing. For right, I have to calculate maximum of left, sorry, not left, right, maximum of right, comma, DFS of, why I am using square brackets here. That's why I thought like something was not correct. DFS of I, and here also DFS of I. Okay, hope you get it. After that, I have to take maximum of that. So I have to take maximum of these two. So maximum of, like, I have visited everything, so I have to maximum of left and maximum of right. I have to take maximum of both cases. So why can I go from left and right? Plus one. Why this plus one? Plus one means me. I can visit myself as well, right? So that's why. So if you consider this four case, this six case, these two cases, I cannot go left, I cannot go right, but I can visit right. So that time for this six case, left will be zero, right will be zero, because everything, this loop will not work, this loop will not work, so everything will not work. It will be zero, but I can visit myself, right? So that's why plus one. And where I am getting this, storing this thing, obviously I can store inside my memory because this is the current place I am storing. I have to store, so I have to store inside the memory. So this is right memory of the IDX. I have to remove any again. Memory of IDX. So this is the maximum value, and return, I can return this same thing. So this is the value I can directly, as I am memorizing, I am writing, storing into directly in memory. So return my memory of IDX. Finish. Simple, as simple as that. So this will be my final function. So what will be the time complexity of this problem? So let's see. For this is a big of n, correct? Now if you notice, for big of n, I am calculating DFS. Now what is the calculation of this DFS? See here, I am coming here. This will run from big of d time. So it will be d time. This is also big of d time. You can say there is also DFS. You can say also DFS. So it's a recursion problem. You can say also DFS, like this will also go for d10. So if you notice earlier in this example, when I am calculating this one, I may calculate this one, may calculate this one, and that time when I am calculating this one, like this 13, it will calculate 9, it will calculate 7, it will calculate 10, it will calculate 6, all of the cases. So one time it may take a long time, but whenever I have calculated, that means when my index comes this place, this DFL takes big of one time because it is already calculated. It is also comes big of one time because at time when it comes, like for when I am doing 14, I have calculated this, I have calculated this, all of this I have calculated starting from 14, right? All starting from 14, I have calculated this. If you hope you understand why you are saying this, because from here I can come here and here I can calculate this. So when I am calculating for 14, it may take time, more time for 14, like because I am calculating these. Okay, so it may take more time in 14, but it will save the time for the others. Like when I come back here, this is already calculated from 14. When I'm coming from here, it is calculated already from 14. When I calculate from here, it is calculated from 14. I'm calculated from here, this is calculated from 13. That is already calculated by something. This is how it works. That's why for for one particular index, it may take a long time, big of n time. If it is take big of n time, for an example, if you think like from here, I can calculate for every index from here, here, all case I can calculate. If you take all case calculate from this, it may take big of n. This entire thing take big of n. But earlier one, the later of that, it will take big of 1 because that is already being calculated by that previous case. So that's why it is take only big of 1 in that time. So that's why I'm saying it can run big of n, and it may at most run big of d time. Big of d time, this DFS. At most big of d. Okay. So this will be big of d. This will be big of d. This will also big of d, because no matter what, I have to iterate from d, right? From d. I have to range from index I minus 1 to d, I plus 1 to d. So that's why big of d time it will calculate. So that's why it will be time complexity will be big of n into d. But if you remember, d could be less or equals to n. So in the worst case, it could go up to big of n square. If d is equals to n, if that is the case, it go to big of n square. Space complexity, space complexity is nothing but big of n, because we are taking one space for memorization. Big of n. Hope you get it. Okay. Now, if you want to convert this problem into bottom-up approach. So bottom-up approach, if you notice carefully, what I actually need here, I can take this thing and convert this thing in the bottom-up approach. I will show you how. Okay. But if you notice this case, for bottom-up approach, we have to notice, like, for calculate this one, what I actually need to calculate. From calculate this one, I need to calculate this one actually, right? Isn't it? And for calculate this one, I need to calculate all the lower value. All the lower value I have to calculate. So I cannot directly start from left to right or right to left. It is not possible. But for this one, I need this one, and I need this one, I need this one. This kind of thing I need it, right? I cannot directly start from left to right, left to right. This is not possible. Correct? So from where can I start then? From where can I start? So if you notice, I need to calculate this the smaller, from where I cannot go any places. From where I cannot go any places. So smaller value I can calculate first, then I can look to the higher, larger value. What I mean to say, if you notice carefully, okay, it is already 1 hour video. Fine, good. So from here, I can come back here. I can come back here as well. So for this, I have to calculate this one, correct? Then I have to calculate this one. So I have to calculate the smaller values first. So I have to calculate, if I calculate this one, I need to calculate this one. This is a smaller value. From here I can calculate this. Come back here. From here I can calculate come. So what I am saying, like, I have to calculate the smaller values first, then I can use this kind of thing. Okay. So for that, to calculate a smaller value, I have to sort this thing. I have to sort this thing. Sort this thing. Okay, like sort based on the smaller value, then I will start calculating. Or that's based on the smaller value. Okay. So let's start with this is the approach one. This is the approach one. Let's move to the approach two. It will be much faster, I guess. Approach two. So what I need this function as first. Let's take the whole function because some of the things already written. No need to calculate again. As well, write again. Copy, paste this one. Uh, Up to this I need. So let me remove this part because I can write later. Delete. Okay, maximize little bit. Okay. And I told you I have to, so that means I have to sort what? So that means I have to sort based on the values present. I have to sort based on the values present. Then I have to iterate by index. Correct? So if I take this example, this array, if I take this array, let me explain it fast, then I will give you just a minute. So what I mean to say, so I have to sort these things first. So you see how sorting could help us. Okay, how sorting could help us. So this 4 will come first. This 4 will come first. So if I sort this value 4 0, then what? Then 6 0. This is a value. This is the first thing is value. Second is the index. So this is not a 4 0. This is not a 4 1 4 1 index position. 4160. Then what? This 4 done, this done, then 6. Then 6, what is the index of that? 6 3. Then this is a 7 7 7. Okay. Then okay, another 6 is there, 6 9. So 6 9 6 9. Then this done, then 7 7 7 7. And done. Then what? Then 8 8 4 8 4. Okay. So 8 4. Then what is there? 8 4. Okay. Then 9 6 9 6. Okay. Okay, gone. These are gone. Then 10 8 10 8. These are gone. Then what? Then 12. Sorry, 12. So 12 10. Okay, 12 10 gone. Then 13 13 what? 13 5 and 14 2. 14 2. Okay, these are gone. Everything is gone. Okay. So what I am saying, let's calculate the smaller values first. So if I calculate smaller value first, in the sense, let's see that from the smallest value, where can I go? So what I want to tell, like from here, can I go this place? Yes. Is it? So from if I calculate, this is the fast, this is the fast, this is the fast. So after that, like from here, can I go this place? No, right? I cannot go there. But from here, I cannot go any places. So it will be by default mark will be one. This will be one. This will be one because here I cannot go. So from if I do that thing, like if I calculate from smaller value, like for this place, where can I go? I am checking within my range. Can I for one I cannot go any place. So I will take the first value and mark this thing as done. So this will be one. Then 6 0. From 6 0, can I where can I go? So again I have to do the range thing, right? This thing and this thing. I have to check can I go other places or not. So here can I go? I can go this place because this is already marked. This is already marked. Okay. So if there is anything smaller than 4, and then it will be marked because I got at the sixth place. That means all the places less than my 6 is already marked. That's why 6 I got the 6. From 6 I will go this place, one valid place. So this will be marked as 2 because this 1 plus this 2, this 1, this is a T, this is gone. Then 6 3. 6 3, where can I go? I go nowhere, right? So this will be 1. From 6 3, then 6 9. This is where I can go. I can go nowhere. 9. But D is 2 here. Remember. From 7. 7, where can I go? 7 I cannot go anywhere. So it will be 1 again. Then 7 is gone. Then 8 4. Then 8 4 I am getting. From 8 4 where can I go? I can go left and right. Right I cannot go anywhere, but left I can go, and it is already 1. So 1 plus 8, let this index 1 plus 1 will be 2. This will be 2. Okay. So this is actually I'm doing the backtracking. So this is why I need this is also bottom up approach. I'll come back coming to this DFS. I'll point like map from DFS to backtrack, but you can think of this way as well at the beginning also. And then 8 4 is also done. Then 9 6. From 9 where can I go? From 9 I can go this place. So this 7. So this will be 2. Okay, so it will be 2. 9 go. From now 10 8. From 10 you can see I can go here, I can go here, I can go here, multiple places. So I will take the maximum of that, maximum of the every cases, and plus 1. The maximum is 2, and that is plus 1. That is 3. I can go 3. Then 12 10. 12 will be 12. From 12 I can go 10. So 10 will be 1. 3 plus 1 it will be 4. Then 13 5. 13 I can go here, I can go here, again here, go here. What will be the maximum case? Maximum will be my maximum is what it is given. It is 2 is there. So maximum will be 2 plus 1, that will be 3. And from 14 I can go. I can go maximum in this two second place. So 2 plus 1 will be 3. So answer will be 4. What will be the maximum of answer? Hope you are getting it. How we are getting traverse. Now how to map this thing with the DFS. The DFS, as I told you earlier, when we are doing the DFS, we are doing what? We are doing when doing the DFS, what we are doing actually, we're coming to an index and going back to the all possible places, all possible cases. So here also I'm coming at the when I'm coming this index, when I'm coming this index. So DFS I can do any place. I can start from any place, right? So here also when I'm coming in this place, like it could be I can visit this early this thing first. I can visit this thing next. I can visit next thing next. This is the possible, but sometime I'll visit one index, right? So in that case, whenever I'm visiting one index in the DFS, when I'm visiting one index, I am taking the range. I'm taking the range. Okay, like in the range, what it could be the what are the possible cases I can go and what could be the maximum case. I'm doing the range. Okay, and but here I am actually finding an order. I am finding an order. I am not in DFS. I am doing sequentially because I know if it is not calculated, I will calculate in the DFS. It's a recursion. If it is not my current value is not calculated, so I will calculate, right. But in the bottom up approach, I cannot do this thing. If it when I am finding a, like I am starting from the smaller problem and going to the bigger problem. And top down approach, I'm coming from the bigger problem, then I split the problem, right? So when I'm splitting the problem, that means if the problem is not solved, I'll solve this. But in the bottom up approach, my smaller problem should be small, should be solved. Then I can actually merge those two problems. This is my bottom up. Bottom up, we start from the individual problem and start merging and getting the bigger answer, bigger problem. That is a bottom-up approach. So that's why bottom-up approach I'm finding an order. So if I start from DFS, if you see from the top down, at the end where I am getting what is the smallest value from where I cannot go anywhere. So that is the case I have to calculate that first. So what are the possible cases where I cannot go anywhere? What is the smallest value? What is the smallest value present in the array? From that place I cannot go anywhere. I could go like see here from the 4 is the smallest value. I cannot go anywhere. Or 6 here, after that next is 6, next are the 6 value. You can start any 6. From this 6, you can see like if any smaller value present in left hand side, so that is already calculated because I am starting from the smallest one. If there are 5 present in this place, then after 4 I should have calculated this 5, not this 6. So I have calculating this 6 there because I am assuming all the smallest value I have calculated. Why I am saying smallest not equals to, because the question is I can jump only stick to the smallest value, not to the equal value. So that's why I'm saying that 6, I'm calculating 6. That means I've calculated all the values less than my 6s. So that's why I'm calculating. So I can get this 4 as a valid case. So when I'm coming this 4, it's already calculated because that this value is less than 6. That's why it is calculated thing. So there's the reason I am saying I am finding a order by which order I should visit, not sequential. Hope you're getting it. So that's why I'm finding an order. So in this case, my order is like smaller. I'll start visiting the smaller value first. But when I'm getting any index, I will take all possible cases like that. What I was doing in the my recursion. I'll visit all the possible cases, all the possible ranges, and I'll find like what could be my current case, like what could be my best case actually. Okay. Hope you are getting it. So I have to write a function in and I need an empty error as well. Let's say I need an temp error. Temp error. Okay. So temp is nothing but it's a one empty, let's say vector or array list or something. Okay. So vector, why am vector is not a simple array because I have to put my value and index. Then I have to sort based on my value. Okay. That's why it's a vector or array list or something, you say array list. array list. Okay, anything is fine for according to your language. Then what I have to do, so I need a for loop for I equals to 0, I less than n, I plus plus. I have to insert this thing into my the array. What is that? That is that 10. If there is any direct function, you can sort this thing. You can sort it based on the value. I actually don't know what is the any function present in C++ or Java. That means that's why I'm writing a generic cases. So what I want to say, like inside the 10, you can push back or add. You can add what we could add. I can have to add first value and this corresponding index, that is nothing but I. Okay, I have added this thing. Okay, then close the loop for loop. Then I have to sort. I have to sort using the lambda function. Uh, Please write your lambda function according to your language, because lambda function is not a generic function or any no generic syntax is different from language to language. So I am writing a lambda function notation. So you have to sort this thing. Basically, you have to what do sort sort this one. So temp dot sort. Okay, temp dot sort. Now write a lambda function here to choose lambda function to choose your you have to sort based on the error of like the first value. If there is one pair is present, if the you can say the pair is present, so lambda function will have to write a lambda function to choose the first value of the pair. Okay, lambda function to choose, like let me write a note actually. Lambda function to sort the array or list or vector array based on first item of the pair. First item of pair of the pair. That you write a lambda function regarding that. Okay. Hope you will write it. After that, our thing is sorted. Now we will start doing it. We'll start doing like we can take this DFS code and let me help you how to do that. Let me take a copy paste. Okay, I take a copy of that. Now see, now I have to iterate. I have to iterate based on what? Based on this temp, current value temp. This temp is sorted, right? So after sort, it looks like this one. What is the index present? What is the index present that time? Based on that index, I have to iterate, right? So I will iterate for each item. So let me write another loop for each item present in this temp. I have to iterate. Okay, and I need what I need right now. I don't need the value, I need the index. So I'll write idx. Index is nothing but my item of one. This is my first case. So this is my item of, sorry, not item, item of one, because it's a pair, right? So this is not, I need this index. So I got this index. So as I told you, when I reach the index, I have to do the same thing. This following thing I have to do. I have to iterate, like go to left side and check whether it is case or not. If it is the case, then I have to break. Otherwise, I'll take this left and then right. Then I have to do the maximum. Every same thing I will do. Every same thing I will do. So I will directly copy paste the thing. So left, right, everything I need. Whatever I have done here, I told you, I will take the everything. Because this is the case. Like when I get that index, after that index, I have to iterate each and every case. I have to iterate each and every case. So what I will do, let me take a copy here. So return is not required. These are the required. Copy and let's paste it. Everything I will paste directly. Same thing because same thing I have to do. In index return statement I no need because thing is this earlier this line I no need this line because if it is not 0 it is already calculated. By default it will be calculated. So left will be 0, right will be 0 as always as earlier. After that I will calculate this left and right same way, same thing as I did earlier. Let me reduce some space, otherwise it will not fit here. Okay, let me reduce the space and come back. Okay, now if you notice here carefully, there are three things I need. First one is this memory. I didn't initialize any memory, right? So let me initialize the memory as I did earlier. This memory. Also, I need the answer as well. Like what could be my best case? So let me initialize two cases. One will be my memory. Let's say memory equals to nothing but it will be an array as earlier. It will be an array of n. I will initialize with 0 and one will be my answer that will be also initialized as 0. Okay, so here if you see here I will put in the memory like initially by default no memory will be calculated, so no need of writing this space. Like I am coming this place, like whenever I am iterating this number I know like that place is not calculated, I have to calculate. When I'm coming this thing early or whatever the possible cases I can go here, like what is the below than 6 that will be that has been calculated. Okay, that's why no need to find. But another thing, this is DFS. This DFS or no need to write DFS. You can directly change with the memory of I because that part is already calculated. I knew it. So all the smaller value than current value, all the smaller value than the current value is already calculated. So you can directly write memory of I. Okay, so that's all we have to do. So this is where, and another one last line we have to do. Answer could be my maximum of current answer, and or could be a memory of that index, Okay, this could be the case, or you can directly put the value here. This thing, whole thing, you can directly put the value in this place because this is nothing but this memory of IDX. Okay, and this is the case, and I am stopping the loop. Yep. So, and at the end, I have to return the answer. Simple, return the answer, and stop the loop. This is my bottom-up approach. Okay. So it will be a larger one actually. Okay, it's coming here. Okay, let me remove this DFS function and okay, let's see what is the time and space complexity for this problem. Actually, it will be the same. If you notice this one is nothing but big of n log n. Sorting, not this one. This sorting, this is big of n. This is big of n. This sorting takes big of n log n into log n. Okay, this is the sorting function. This will take big of what big of n because I'm filtering each and every item and temp is nothing but containing every item big of n. This will be big of d. This is also big of d, right? So this whole thing is give us big of n into d as earlier. The time complexity is nothing but big of n log n plus n into d, and we know like d, if it is d is nearly equals to n, it will be becomes big of n log n plus n square is a greater, so it could be equals to big of n square as earlier. And space complexity, again I need an extra space like memory and temp variable, this kind of things, so that's why big of n. This is a time or space complexity. So this is a one approach we could solve it. Now this video is like our constraint is very low. You can submit this thing and solve the problem. It will accept it. It will be get accepted and it will find this is a solution. But could we reduce? Could we reduce the value of n square? So because it's a high value, it's a high value. Could we reduce the case? So let's see. Could we reduce the case? The video becomes gets very longer. That's why I'm uploading a second video on that. Because in the same video, if something gets corrupted, I have to build a second video again, whole thing again, and that is not a good thing. And as it is a kind of valid answer, it is also accepted in the LeetCode. That's why I'm putting this thing. Okay. So see you in the next video in the second part of this video. And as always, if you find any mistake from here in this video, please let me know so that I can rectify. And if you find any useful information on this topic, please also comment it down after seeing my second video because I am giving another case in the second video. Okay, thank you. Bye bye.